Okay, so welcome to a workshop on graphical user interface design in Java. We're going to be using Java Swing today, and I have not prepared a slide deck because the last time we did any sort of live programming, it was a hindrance, and we lost 10-15 minutes of time flipping back and forth between the PowerPoint and the IDE. So I'd like to tell a little bit about the workshop and what we're going to be addressing today. As you know, Java, well, maybe you don't know this, Java comes packaged with an entire graphical user interface library that allows you to spawn windows and configure custom UI components very easily right out of the box. It is generally platform independent so long as you're not loading like fonts that the other operating system doesn't have. You can definitely end up with platform dependence issues in Java based on how you use it. But Swing will generally run anywhere that supports Java, and it allows you to make applications that are much more user-friendly and dynamic because you're not relying on the command line and what you can print to the terminal. So the workshop is going to take us through designing today's version, just some simple apps, and we're first going to discuss why use graphical interfaces in the first place and some of the problems that they might help solve for users. And yeah. I also intend on showing some IntelliJ features and how to do this stuff faster and with less effort to you, because there is a very, very, very long way to approach this stuff. So hopefully with the short way, we will get everyone rolling soon. So I'm going to make a new project in IntelliJ. If anyone is following along, I encourage you to also make a new project in IntelliJ. So we're going to call this project Workshop. We're going to use IntelliJ's build system, and we're going to download a JDK. This is a fresh install of IntelliJ, so everyone can follow along as if they've never had it. I suppose we can get the JDK 19. We'll get JDK 8. JDK 8. We'll get Eclipse Tamarin. So after we get the new project built, we're going to make a really simple command line application. And then in the simplest way possible, we're going to make it a more graphical user experience. Nothing too crazy going on there. You might pick up some useful Java classes, though, from this first demonstration. We don't need sample code, and we will create. So I'm going to go here to source. Right-click, new Java class. We'll call this simple app. So we've now got simpleapp.java, and the goal of this app, we'll type main and tab to get our main method. And the goal of this app is just going to be simple. The user is going to input exactly 2 numbers, and we're going to display the sum to the user. So to do this with a command line app, do system.out.println, enter a number. Well, let's give more information. You will be prompted for 2 numbers. Yep. Now we'll type sout tab again, system.out.println, enter the first number. So now, actually, I'll do this beforehand. We'll make a scanner to read system.in. Scanner s equals new scanner, and we'll put it on the system.in stream. So now this scanner is going to read what the user types in the console. So we will do now int num1 equals scas.nextInt. All right, so the first number has been prompted for and gathered by the user. In the interest of time, we're not going to do any sort of input validation on this, at least. We can do some input validation with Swing later because it might be more nuanced and interesting that way. However, we're going to now copy and paste our code to get enter the second number. And we're going to make a new int and just kind of define it the same way as s.nextInt. So now we are going to system.out.println num1 plus num2. And we will give this a quick run. Nothing amazing here. This is probably one of the first applications you'd build in any college curriculum. So enter the first number arbitrarily. We'll pick 10. Second number, we'll pick 50. And we get 60. That's just as we expected. We've got a simple app. Now, for something like this, I don't know if a graphical user interface would be too compelling to make because anyone can read and enter a single number, press enter. But let's say you did. Let's say you want to make a really simple form of adding like a more graphical experience here. In addition to printing to the console, we can call JOptionPane.show message dialog. We don't have any other swing components, so the parent will be null. The title will be, or we'll do untitled. Your sum is plus num1 plus num2. But we need to put these in parentheses because they will be interpreted as strings otherwise. So now we'll see what happens when we run the application. And if you're already familiar with JOptionPane, we are actually making our own swing frame soon in this workshop, so just bear with me here. We're going to enter 10. We're also going to enter 50 again, and we get 60. And we don't seem to have the message dialog. Now that's strange. No, why we don't get the message? Let's put it in debug and see what is happening here. Wow, technical difficulties. I recommend if anybody is ever planning on hosting these kinds of things, you should get your own laptop, as borrowing them can be a hassle for reasons just like this. So we're running our code, and we're not getting the message dialog to come up, which is a bit disconcerting because this should have appeared. This should make it appear. I just want to try something. JOptionPane.show. So we're going to try to display a different app to see if it's swing entirely that's breaking, or the JOptionPane class. 50, 60. And it's simply not spawning the swing components. Now that is strange. I've not run into this before. So as far as these JOptionPane classes are concerned, we are going to forget about that for now and dive into making an actual app version of this number sum generator. The code that was on the screen should spawn windows though, so it could be the IDE configuration. I'll investigate that later tonight and figure out tomorrow why it failed. So let's say we want to create a dialog class. We're going to go first on our source folder. We're going to right click and go to new. We're going to go to the Swing UI designer. And from here, we can pick either a GUI form or a dialog class. The dialog class is a much simpler option as far as this is concerned. So we'll start off doing that, but we will make dialog forms next. So we're going to enter a dialog class name, and then I'm going to talk a little bit about these boxes. So we'll call this number sum calculator. Okay. So do we want to generate an OK handler and a cancel handler? Why not? We'll do that. So now here we get this class. The IDE took care of this for me. It gives us a content pane, an OK button, and a cancel button right out of the box. And it also, more interestingly, generates this form for us. And this form, I think it's backed by XML or some similar language, allows you to kind of drag and drop GUI components as if you were using Photoshop or anything else that has drag and drop, like Scratch or whatnot. So let's just kind of get some stuff on the screen. So to display text that doesn't need to be interacted with the user, or the user's not like the difference between a label and a text box, we'll see in just a second, or a text field. We're going to take a JLabel and we're going to just call this number 1. We're going to make the text number 1, and we're going to call the field num1 input box. Or no, num1 label. Because the input box is not the JLabel. The input box is going to be the JTextField. And we're going to put this right next to num1. And we're going to call this num1 input field. Okay, so now we've made num1 input field. So now we're going to do the same thing with num2. going to drag here. We're going to put this number 2. And now we're going to make another JTextField. We're going to call this one num2 input field. And these names that we're giving the fields right now, this is how we're going to access them in the code later. So we've now got num2 input field. We've got the num2 label. We'll just call this num2 label, so we can access it later in the code. If you don't give them names here, IntelliJ will actually take care of it for you, but you're going to have a really hard time interacting with it programmatically. So we're going to take care of that now. And let's forget that they gave us the OK button, and we're going to make our own button. We'll put it right here that says calculate. And it actually took a guess at the name for me. When you make a button here, you put the text on the button, it will try to name it whatever you put on the text, camel cased with the word button. There are ways to configure that further if you wanted to do something else, if you wanted to prepend like an M underscore or a GUI underscore, whatever you want. You can set up these templates for when IntelliJ generates code for you to have it generate the code that you want it to. Now, there's one thing this screen is missing. We've got the input fields, we've got the calculate button, but we haven't given it anywhere to display something. So we're going to make a label that holds the sum. Sum. And then we're going to make a label that actually holds the sum. When I said the first label, we're making a label that says sum. And now we're going to call this field name sum field. Okay. So now just to recap, we've created 2 JLabels named number 1 and number 2. And for each of these, we have made input fields, num1 input field, num2 input field. We have made a calculate button. And this calculate button is, the goal here is to take the values of these 2 fields and place them down here in the sum. So we are going to now, this isn't going to work as it is because we haven't programmed any interactions between these components. However, we can generate a little preview of what this is going to look like when all things are said and done. There it is. Preview button. So here we go. We've got this preview generated right here. So num1, num2, I'm just going to enter some stuff. It's not going to work, but we can press the calculate button and nothing happens. But we have roughly what our field is going to look like, provided we don't add a bunch of configurations in the code to change the sizing. Okay, so now how to make these things do anything? Not even the OK and cancel buttons are doing anything. So what we're going to want to do here is go into the, not the OK button. Let's go to the calculate button, and we're going to go to data binding. Or no, not data binding, was it? We're actually going to do this without the form editor to make it more transparent what we're doing. Okay, so we see here in this JDialog in our constructor that it generated for us, we get all of these methods to define action listeners. And we see that there's one generated for button cancel and button OK, and we're going to be doing something similar, but with our calculate button instead. So calculate button dot add action listener. And an action listener is a particular type of event listener that quite literally listens for an action. In the case of a button, the action listener will generally listen for the button being clicked, or in certain interactions where you've pressed a key and bound that to be the equivalent of a button click. For example, the enter key. If you press enter, some applications will read that like you've clicked on the button that was in focus or highlighted when you pressed enter. So we're going to make a new action listener here. And we're just going to use the anonymous or the anonymous class system to do that. We can, as of Java 8, also make these with Lambda expressions. But I think this is more readable for people who are just getting into it. And because action listener is an interface, notice in order to use the new one, we actually have to define all the interface methods that are required by the action listener. This might seem a little foreign or a little bit like, wow, this is a lot. As we do a couple more of them, it will be almost rudimentary how to do these interactions. So when we click the calculate button, what is it we're trying to get to happen? We'll go back to our form really quick. We want the value of this field and this field to appear in this label. And this label we have called, once more, sum field. So what do we want to do? We're going to say sum field dot set text. Actually, we'll do it this way. So int num1 equals num1 input field dot get text. Now, this is going to be a problem because .getText gives us a string. So we must cast to int. Or no, we have to use integer.parseInt, I'm sorry. Integer.parseInt, and that will take a string value and attempt to get us an integer out of it. Nothing too crazy there. So we're going to get the value from the num1 input field and store it in a variable called num1. We're going to repeat this for the num2 input field. We're going to do num2. Num2. Okay. So now we want to make the sum, and sum equals num1 plus num2. And now we want to take the sum field and set its text to sum dot toString. Oh no, it has to be integer dot value of integer dot toString sum. Okay, so the logic here, when the button is pressed on action performed, we are going to store the value of the num1 input field in num1, store the value of the num2 input field in num2, add them together, and change the value of some field, the text property of some field to read the sum. And we will see if this works. So we can run this class. Typically, you'd have more to your application than this dialog class, but IntelliJ allows us to generate a main method that we can run right out of the box. And that will be nice. So we've got two numbers. So let's get a number 50, 100, and now we press calculate. And we have got our value. It gives us our sum. We can change these and recalculate. It gives us our sum. Easy enough. So we did some class casting nonsense, or more integer parsing with no input validation. So if we wanted to do this in a bit more of a validated way to prevent the content from being terrible, if integer.parseInt num1 input field.getText so we'll just try. So if we get an exception saying that the integer.parseInt has failed, we are going to catch any exception, and we are going to the action listener event is called E, so we'll call it exp. We will catch any exception and take the sum field dot set text to be error instead, and we'll also just sum field dot set foreground color dot red. Foreground should be the color of the text, and we're going to change it to say error instead of trying to give the user a sum. We get our sum, and now we'll put in the word apples, and we get error. So upon any exception, in this case, we know that integer.parseInt will fail for non-integer values, so we can just catch any sort of exception. You should, in practice, catch a more specific exception, but frankly, I can't remember which specific exception gets thrown. It should be some type of IO exception, though. So here's a really simple kind of Swing app using the IDE's GUI editor that we made to do this sum project, or the sum calculator. So this is a little bit better than the command line for a few reasons, in my opinion. I think that one, performance is not better. So we're not going to make an argument that this is technologically superior with regard to saving your system resources. But in that the user can see all of the data at the same time, it allows them to more reliably backspace without entering key combinations and commands. you might say that the user has an easier time using it, or there's less chance that they mess up the input, or at the very least, less chance they need to start over to get something working. However, there is a lot more that we can do than make these buttons and the labels. So we will start off, well, we're not going to start off anything, forget I said that. But we're going to now try to add a new feature to this app. And a really nifty class is the swing timer class. So we're going to make a timer in our class as a variable, private timer, our timer equals new timer. Of seconds. Of seconds. So duration.of seconds will get us a time object. Delay, what does it want for delay object? Oh, it just wants int. Okay, so we'll just do delay 10. What else does it want? Oh, initial listener. Okay, so now we're going to make a new timer and we're going to make the initial listener null just to show more how we're going to create the action listener for the timer. So now we're going to go to our timer, dot add action listener, new action listener. And what do we want our timer to do? How about we just show the user how long they've been using the app for? I think that's somewhat reasonable. We'll put something up here, down here we'll do application runtime, and then we'll make another label to display what the application's runtime actually is. We'll call this duration field. Okay, so we're going to also on our class store a variable private int time elapsed equals 0. We'll start off at 0 every time. And when our timer is started, we are going to, when our timer ticks, rather, we are going to update time elapsed plus equals 1. So we're actually going to change this to delay of 1. And we now have, we've added our action listener. We set time elapsed plus equals 1. And now we're going to take duration field dot set text integer dot toString time elapsed. We'll even do plus plus for later notation. So now we've got our action listener, or we've got our timer. It's been made. It's we've added an action listener to it. The only thing left to do, like with any timer, is to start it. So we add the action listener to it, and now we can start our timer. And hopefully this should run. Okay, so clearly it's not counting seconds like I hoped it would. But as you can see, every millisecond it appears, our action listener is getting called and our application runtime is constantly increasing. So that's neat. Let's say we want to stop the timer if the user presses calculate. Let's just do that. We can simply do our timer dot stop. So now we're going to take the amount of time until a user presses the calculate button. 50, 60, and calculate. And we're frozen there. So there we go. The timer has tracked how long it has taken us to press the calculate button. You can do a lot within these timer action listeners. If you wanted to, When I think of timers, I usually think of games or some kind of user interaction where there's a challenge or you must do something quickly. Let's say you wanted to make a quiz game or a timed hangman. The swing timer class is a great place to start. With swing, I should have mentioned initially, swing is single threaded. Everything that updates a swing GUI component must be used on the event dispatch thread, which is a special thread that is spawned by the JVM that handles everything, anything and everything to do with swing, plus a number of other important functions. And the swing timer accounts for this. And it's very easy to work with compared to, there's another, you can use the system timer, and we can make an alternative implementation of this where we do, do time elapsed, and we'll do private int time started or something. So there's an alternative to doing this that will not work so reliably, especially as you get into more complicated use cases. And I will just show kind of what that would look like and how kind of frustrating the alternative might be there. So time started, instead of our timer.start, we're going to do time started equals system dot time, current time milliseconds. Okay. And it doesn't like that because that's a long. We should convert to a long. So I'm going to right click here, show context actions, and I'm going to migrate the type of time started to a long, which allows me to just IntelliJ has now gone up here to my time started field, which is not in view right now, and made it into a long. So we can track the time we started, and then over here in the calculator, we can go, or on the calculate button rather, we can do some field, or no, it's a duration field dot set text long dot parse long time started, or no, we'll do current time system dot current time milliseconds minus time started. What is wrong with that? Query type, oh, long dot, oh, it's not long, it's long dot toString, sorry. Long dot toString. Okay, so now this is going to get out of hand really quickly. And as you can see, we can't just start it and stop it. We can't so easily reset it to change the functionality of this. There's not a, because if you should work with swing more, you'll get used to seeing the timer. Like the timer is a very useful thing. And when you see a swing timer, you know, oh, there's probably at least one action listener on this. When this timer ticks, it's going to do this. And you'll look for that. Whereas this, we're getting into storing variables, doing math on the time. The swing timer does this for us. So if swing gives you a class to do something, I recommend using it instead of trying to work around with your own lower level solution because of how threading works in swing. If you get too deeply into trying to make swing work in multi-threaded context, you can get these really nasty errors that can take very long to debug and might require great redesign of your application depending on how you went about addressing threading. Okay, so now we have the application's runtime. It's tracking it. And let's say we wanted to, instead of showing milliseconds, let's get rid of all this duration stuff. Instead of showing milliseconds, let's show true seconds. So we will do, instead of 1 for the timer delay, we will do 1,000. So this should give us 1 second for every timer tick per se. Yes. Okay. So now our application is tracked in seconds. Cool enough. So let's make a simple button just to reset the runtime. Just to kind of enforce the idea that we're going to make a button, we're going to add an action listener to it, and the code is going to do something for us. So we're going to make a button. We'll call this reset timer. And then IntelliJ calls it reset timer button for us. That's awesome. So I can go in here now. I can access my button with reset timer button dot add action listener. Is going to be a new action listener. And on action performed, what we're going to do is timer. We'll do our timer dot stop. Yeah, we'll make a start. We'll make a start button. I guess it doesn't really matter. We'll make a start button too. Our timer dot stop. Our time elapsed dots just equals 0. And that should be fine. We can update the field here. Duration field dot set text 0. Okay, sure, that's fine. So now we should be able to stop it with our reset timer button. So we're counting up, we get to 5 seconds, and we're going to stop. Cool. It stops, it doesn't start back up, and it resets just like we told it to. So yeah, that's pretty neat in that we can control our timer outside of its own. We can just interact with it like it's a Java object. And because it is in the Swing library, Swing works out very well with it. So now, because I brushed over a lot of the cool stuff that we can do here in the form editor, I think it would be worthwhile before we develop more complicated applications to address some of this and some of the cool nifty things that we are capable of doing in here. So I'm going to start off on this property browser over here. And you see it shows the property on the left, value on the right, pretty standard stuff there. So the field name, this is the name that the generated Java class will actually be called. So the reset timer button, we can call reset timer button dot something, or anything that takes a button, we would pass this button through by calling it reset timer button. The custom create button, when you're playing around with this, I don't think you'll need to mess with it. There's not too much that you might need to do. However, it will give you a code block for us to reconfigure some more things, or it might actually cancel some of the code generation with the expectation that you'll do it yourself. Haven't run into too many use cases with this GUI designer where you need to do that. But this is also not my preferred GUI designer, and we can talk a little bit about that later. So the horizontal size policy, we will allow this button to shrink and grow. Sure, that's fine. But there are other options here, and that's kind of, does it want to grow? Sure, maybe it does. And when it says to grow and shrink, let's say the window resizes, and we'll see how it behaves now before we start making changes. Say the window resizes, what's going to happen? So notice the reset button, this timer button is set to grow. It can grow, so when our window grows, Swing wants to make it look nice. So it grows. Now let's say we turn can grow off, and we rerun it. We expect that the reset timer button will not get any larger as we stretch it. And the reset timer button is not expanding quite as fast, but the cell that it is in is. So if we take the horizontal align off of fill, because what fill will do is it will fill your component to the size of the container that it's in. So despite telling it we can't grow, we are still telling it to occupy all of your space. So we will do a left alignment. So within its container, in this case, it's this panel here that see, what this GUI designer is actually doing, I have not told it to make a J panel, but when I put a component down, it knows that the panel needs a container, so it makes a J panel. So num1 label, or actually that's a poor example, but the reset timer button, that's what we're looking at. Sorry, the reset timer button lives in a particular panel somewhere, and it matches the size of its container. And now we've taken that off, so horizontal align is to the left, and we should see that it does not get larger anymore. As we can see, the button is no larger. We have deleted its capacity to grow, and we have also told it no longer to fill the size of the container that it is in. Okay, so vertical align, you can do similar things, top, bottom, center. In this case, there's probably not too much space for it to see what this would do, but we'll put it on bottom align and see how it behaves a little differently. Bottom align, and now as we make it big, you'll see that it stays down here. If we switch this to top align, it will go to the top of the container that it's in, as we will see in just a second. No matter how big we make it, it's going to stick to the top. And it might not look like it's going as high, but of the component that it has actually found its way into, that is the top of it. Instead of ending up way down here, it's staying fixed there. So with the indent, how far away from each side is it? Nothing too special. Minimum size, unless you really know exactly what you're trying to do, I would probably refrain from touching these sizing components until you absolutely have to, because it is a fast track to get things mixed up and confused. Each of these size properties does more than their names would lead on to believe. I think that we should better save some of those complicated interactions for tomorrow's workshop as we get into things like scroll panes and making sure that those are configured correctly. But just as like if you're playing around with this tonight, don't change around the sizes until you really need to, or you know exactly what they should be and what they're doing. However, you can set these components up like these size variables, size properties. The background color is going to be the background color of the actual button, the component itself. So in this case, let's just run it. I think that we have some look and feel manager that's making it look different for us. However, actually, no, that's the text color. The foreground is going to be the button's background, I believe. So we should be able to go here, take this copy and run. We should now get a red button. We don't get a red button. Did it change? Oh, it also doesn't look like it updated. Red, okay, there we go. Now it should update the text to be red. No, I was right the first time. Okay. So despite it saying that this is the background color that we're using, IntelliJ's look and feel manager is, or the actual swing that's running is replacing that with a different look and feel, which has a default background color for buttons. But as you can see, we've changed our text to red by setting the foreground property on the button to red. Simple enough. And in the code to get this to happen, we can just, we kind of did this already, but we'll do it with the calculate button as well. When we press the calculate button, let's change it into a random color. Sure. Calculate button dot set background color dot, let's say blue for now, and we'll incorporate some randomness in just a second. Random r equals new random system dot current time milliseconds. And while you see it in most examples for usage of the random class in Java, system dot time millisecond, it's not reliable. There are actually a lot of ways to exploit timing with using system dot current dot time. I'm not going to get too deep into it, but Java provides something called secure random, which uses a much more intense, it uses more intense measures to ensure that the number is not predictable. As you get into hardware-driven hacking or hacking that revolves around taking advantage of hardware, timing is one of the most exploitable things possible. So random is not particularly safe, and if you're relying on it in Java, do not use random, the class random. You should use secure random or something stronger, provided, of course, that your server hardware or your client hardware, whatever you need to generate the random number, is configured in a way that will do it. Certain VMs do not process information in the same way, and thus will give you an even less random number if you choose to go the secure random route. Alas, that's a bit of a tangent, so we'll call int r equals r dot, oh, we can't name it r, red equals r dot next int 255 int rand green equals r dot next int. We'll do 255 int rand red, or not blue, equals r dot next int, and also going to be bounded with 255. So we're going to set background new color rand red, rand blue, and rand green, or no, rand RGB. Rand green and rand blue. So one of the constructors for the color object is simply a red, green, and blue. You can get into much more complicated colors as you start playing around with the alpha and other opacity properties for the object. But red, green, and blue. So the goal here is when we press calculate, our button will turn into a random color each time. Okay, oh, we errored out before we got to that. So we need to provide valid numbers if we want this to actually happen. Or we can simply take this logic and put it before the try block. Let's do that. Control X. Now we know this isn't going to error out, so we can put that up there. And we can rerun. So what happened there is upon trying to parse the empty field as an int, we ended up hitting an exception, which skipped ahead of our code that's supposed to change the color into our try block. But now, calculate, we've got a different color, different color, different color, different color, different color, so on and so forth, just bound right into the calculate button. Similarly, if we want to do the same thing with the reset button every time we press calculate, we could do something very similar. And let's make them different colors. And we are going to bind this to, or we're not going to bind, we're going to put it on the reset timer button. We'll change that. So now we'll see here when we press our button, we will get both colors, or both buttons changing their color dynamically. So no matter how many times you press it, you're going to keep getting a new color. We can start recoloring other components all we want, but I think we've gotten the point across that colors can be changed at runtime by setting a particular property on the swing component. Which, let's go more user experience stuff. Let's say the goal here is to only ever calculate one time. Let's say you only ever want this calculate button to be pressed once. And, well, how do you do that? There are numerous ways you can approach it. You could close the application after you press it, for example. But the implementation I'm about to show you, we're going to make it so the button is no longer clickable. You've all dealt with a grayed out button or control in your life. Well, Swing allows you to do that very, very easily. Calculate button, and we're still in the calculate button action listener. So we'll do it outside of our catch block because no matter what happens, we're only pressing this button once. Calculate button dot set set enabled, and it takes a Boolean false. So let's say on the reset timer button, we also want to re-enable it. We can simply do in that block. Oh, I actually put this on the reset timer button. Let's put this on the calculate button. Calculate button. No, I actually did put that in the right place. We'll just put it at the top of calculate button though. We're going to disable it. Calculate button dot set enabled false. So then in the reset timer buttons action listener, we're going to set enabled true on that. Reset timer button, calculator, set enabled true. So as we can see now, we're going to start up. The application is running, and we're going to type in 50, we're going to type in 60, and calculate. So now I am unable to press this button. It's hard to see with the actual color that it shows, but it is disabled. We can no longer press it. And let's try to get ourselves a new sum. Well, the button is disabled, so no matter how many times we click on it, it won't do anything. We reset the timer, however, and we get our button back because we changed the enabled property to read true after you press reset timer. Button goes away, button comes back. Button goes away, button comes back. Or that's button goes away again. But yep, you can set any component. So let's say it's really important that number 1 doesn't change after you press calculate. Well, text fields also have an enable property. And as you're probably guessing, the text field, when you set enabled to false, you will no longer be able to enter text into such a field. So if on the calculate button, we say num1 input field dot set enabled false, when we press the calculate button, we're no longer going to be able to change num1. So we'll do 500, 700, and calculate. As you can see, this field is no longer within our control. And there are plenty of times where you might want to disable one particular place for the user to input something. Maybe you've got logic where you might need to input something situationally, so it's better to use the text field that supports gathering input in comparison to the label that doesn't. But if you ever need the text field to serve more like a label, you can simply disable it for however long you need to, re-enabling it only when the time is right. We can press reset timer to reset our calculate button, but because we never said to unbreak or re-enable this text field on the reset timer button, it simply won't happen. For the sake of reinforcement, we're just going to add that functionality really quick. num1 input field dot set enabled true. So now, similar to the calculate button, when we press the reset timer button, we should get our num1 field back, or the ability to type in our num1 field back. Calculate. Okay, it's disabled, reset timer, and we get it back. It is enabled. Cool. So neat. We've got our buttons. They're doing different things, but there's not really too much interaction with the components between each other yet. So let us make a checkbox. So we've got a J checkbox. This is another object. It is another swing component, so to speak. And we're going to call this our checkbox. Checkbox, yeah. Okay. So why is it reading that as a label? Did I not pick checkbox? I think I picked JLabel instead of JCheckbox. So let me get rid of that, as it should not be there. And we'll do JCheckbox. There we go. And we'll call this our, or no, we'll call this do nothing. So do nothing box. So let's say we want to make a checkbox that prevents our application from doing just about anything. And in this context, I mean, our calculate button will not work, our reset timer will not work, and let's disable the fields too while we're in there. So similar to our other components, we are going to put an action listener on this checkbox. So just down here after our other action listeners, in the constructor for this class, we will do our checkbox, or no, was it do nothing box dot add action listener, new action listener, and on action performed, what do we want to do? We're also going to do something else here. We're going to do Boolean GUI enabled equals true. So when you press the checkbox, do nothing box. When you check the checkbox, or when it's clicked, if disable, did I define that in the wrong scope? GUI enabled. Oh, it's GUI enabled. That's one. GUI enabled. GUI enabled equals false. Else GUI enabled equals true. And then we are going to leverage we're going to make a new timer. And this timer is just going to check whether or not the box gets, every 5 seconds, we're going to see if we need to update. So make another timer, private timer, do nothing, check timer. And there's actually a different action listener that we could use to check when that property is changed, but for the sake of building on timer and showing more use cases, we are going to go that route. Equals new timer, and we're going to have null and, oh no, it's 1 and null. Or we could actually just do the new action listener in there, but for the sake of consistency, we will go through and make it just like we made our other timer. This time I'm very deliberately putting it on 1 millisecond. We just want to check as quickly as possible whether or not we should disable everything. So for this one, we called it do nothing timer. So right beneath our do nothing box action listener, we're going to add an action listener on do nothing timer. Do nothing check timer dot add action listener, new action listener. And what we're going to do here is if GUI disabled, GUI enabled, num1 input field dot set enabled, or no, we can actually do this even better. Num1 input field dot set enabled GUI enabled. So whether or not our GUI is enabled, we're going to make num1 status equal to that. Num1 input field status, sorry. And when I say status, I mean to say whether or not it is enabled or not. We're going to do the same for num2. We're going to do the calculate button dot set enabled, GUI enabled, and finally the reset timer button dot set enabled, GUI enabled. And the hope is right out of the box, this is going to work, and it should if I start my timer. Do nothing check timer dot start. So hopefully every time we click that box, we will unmask, enable, or disable everything. And check. We can no longer enter in our fields. All of our buttons are broken. Uncheck. Check. Uncheck. Check. Uncheck. So as we can see, we are able to make a checkbox and then update a bunch of different components based on the state of a variable that we kind of track with the checkbox. This is a bit of a, I don't know, I'll show you something better in a moment. GUI enabled equals do nothing box dot is, what is the check? It's not is enabled, is it? Oh. I actually don't work with these checkboxes enough to know this off the top of my head, but we'll forget about that actually. GUI enabled equals not GUI enabled. So every time the box is hit, that's going to happen. You know, I'm thinking actually it would not, it's not actually a variable that's stored in the box itself. Alas, we can check it, uncheck it, and it stays in sync with our app. Disabling things with checkboxes is pretty useful. Let's say you wanted to prevent a user, like if you wanted a guest and they said, oh, log in as guest. Boom, we disable the username and password to make it clear to them that they don't need to supply such to log in. Checkbox is pretty useful. The next thing I suppose we should talk about is the JList. The JList is pretty neat in that it allows us to display a list of things. And by things, I say that deliberately, it can be a list of whatever we want it to be. Most often, you're going to see this rendered as strings, and the list will appear as strings, but what's actually in the list model could be quite literally whatever object you want. And then the list will simply render it based on the toString of that object or something to show you how to select it, but you're still able to interact with all of the datas. So we'll make a JList. Actually, we're going to now start a new application to get rid of all of this mess, and it will also reinforce some of the just setup things that we did the last time. So workshop 2, we're going to use IntelliJ as the build tool, Java 1.8. We don't need any sample code, and we will create it in this window. We'll terminate, new, Swing UI designer. We'll just do the dialog class again, as it's the easiest to deal with here. And we'll call this application to, we'll call it select, add, delete, update. We'll just call it select, add, delete panel. Okay. So once again, out of the box, we get these content pane, the button OK handler, and the button cancel handler. By default, they do nothing. They actually call the method called on OK, which, as we can see down here, does nothing other than disposes of the window. but we are going to forget those exist and make our own components here. So we will start off with a JList. And we're going to put this in the left-hand side of our application. Field 1 is, we're going to call this our main list. Okay, so this is going to be our main list. And in here we have some properties. Where'd they go? I hope I didn't just drag that window somewhere else. No, okay. Our main list, awesome. So this list is backed by a list model, and there's actually a list model property. And we can define it in this GUI editor by default. We can just, let's just go add some items to this list. Item 1, item 2, item 3, and item 4. Why not? So we will do that, and it puts them in the list in our little preview here. So let's just run the application that we just made. We should see little more than that JDialog or JList in our dialog box with all of our items in it. And notice these items by default are selectable within the list. So if we just were to, if we wanted to make them unselectable, we can use our favorite property, set enabled, our main list dot set enabled false. And we should be able to rerun, and no longer should we be able to actually click on our list and start highlighting things. Nope, that's grayed out completely. And these features are really good for, one, preventing your users from doing things they shouldn't, and two, making it clear to the user that they shouldn't be doing something at a particular time. It's great if you've ever had a button that was completely unresponsive that shouldn't be unresponsive. You could press it for a while, or you might start checking your internet connection, but really they could have saved you all the hassle by making the button disabled or the text field disabled, or providing a more accurate or informative user experience. So a list of predefined items at the beginning might not be too useful. We want to change this at runtime, I would think. So let us, let's make some features. What can we do with a list? Let's say we want to add to the list. Why don't we do that? We'll do JButton, and we'll make this button, we'll call it add button. I spelled button wrong. Add button. And we'll make the text for add button. We're just going to say add. Okay, so now we've got a button that will add, but what is it that we want to add? Let's let the user decide. So we'll make a text field, we'll put it above add, and we don't need a value here, but we'll do input box. Better idea. No, that's fine. Okay, so we've got our add button, and what do we want to do when the add button is pressed? And how do we interact with the add button when it is pressed? We add an action listener to it. Add button dot add action listener. Once more, new action listener. And on action performed, when the button is clicked, we want to our main list dot get list get model dot okay. So we're going to have to program a little more stuff to do this neatly and in a way that's flexible and understandable. So we're first going to make a collection of items. We'll call this array list. We'll just make them strings for now. Array list string. We'll import array list. Call it string list equals new array list. Nothing too special there. For the sake of things, we're going to get rid of these items in the list model by default because we want to add things dynamically. We don't want all this stuff in there at the beginning. We're going to do this and get rid of them there. Now, when we run, we will not have them. So when the add button is pressed, we want to string list dot add, and we'll do input box dot get text. So we want to add to our array list that's ultimately going to back our list model the string that the user has entered in that box. So list, our main list dot set model new list selection model. That's an interface. New default list selection model. And this should take a collection provided class argument to list model. And string list. No, it doesn't like that. List model. Default list model. Oh. String. Our list model. Default list model. Okay, and now every time we press add, dot add, and we'll do string list. Oh, I guess we don't even need to. Let's not do the backing array list for now. We'll incorporate that in after. We'll forget that exists. So we're going to add the item to the list, and in this case, it's a string. It's a list model of strings, generically speaking. So anything we put in a string, like the text from a box, input box dot get text. And it does not like that, provided int. Oh, it wants an index. Okay. So we're going to need to do, we'll do list model, our list model dot size plus 1. Or no, dot size. We'll do the index of the next one. Yes, that should suffice. Okay, so hopefully now, when we press add, we should get an item in our list. And it is not doing so. So let us see what it is we have done wrong. Swing is fully compatible with the debugger, so I've set a breakpoint here on line 28. And it does not seem to be, I haven't pressed the button yet. Of course, we won't hit the breakpoint without pressing the button. 600, we will go to add. Oh, you know what it is? I made the list model, but I never set the list model equal to. I never set the list model. I did not configure the list that we have on the screen to use that model. Our main list dot set model list model, our list model. And now, for the sake of better programming, we're actually going to strip this out and make this a class level variable, so we do not need to worry about reinitializing it or pulling it. And we can forget the, we'll leave the array list commented out for now because I think we can still make use of it for something. But for now, we've now set our main list model to be the list model that we've just added to. So the hope is now, when we press 500 and we press add, that we should get the 500 in our box. Awesome. So we've got 500 in our box. Let's do 5,000. 5,000 is also in our box. Notice we've set this box to be disabled for right now. We can't select from it. That's fine. We can flip that property at any time, but in case anyone's forgetting why it's grayed out. So we can just add stuff to this. Doesn't really matter. And yeah, basically, again, what we're doing is a JList is backed by a list model. So we're creating a list model object, and this list model object will be strings. And I want to show how we can use this for other things in addition to strings as well, because chances are a user's selection from a box could be made much more useful if it wasn't just a string. Because if all the user is really selecting is a string, and you're going to do anything more with the string that the user is selecting, or with the data that backs it, you're going to need to have some kind of map that maps that string to another object. However, I'm about to demonstrate how we can put something else in our list model because of Java generics and then see how it would get rendered in that context. So new Java class, we're going to make a really simple data class. We'll call it dog. And dog is going to have private string name, private int age, private string breed name. Sure, easy enough. We are going to generate some getters and setters for these. Getters and setters, I want all three of these things that I just made. Awesome, done. Cool, excellent. We've got these getters and setters for our dog. We're now going to get a constructor for our dog. Right click on dog, generate constructor, pick all the fields that we want to be included in our constructor. We press OK. We now have a dog constructor for our dog object. So for the sake of things, we are going to add, we're just going to do an example here where our list selection model is no longer a list model of string. However, it is a list model of dog. And we're actually just going to enhance this app a little tiny bit here so we can actually interact with the whole dog object. So we'll do JTextArea, JTextField, that's better. We'll do JTextField. And here we are. So these are kind of meaningless without labels. We will give them labels. We'll call this name, JLabel, call this age, and we'll do the last one, breed, name. Okay, we've made 3 fields, so we'll call this name input. No. Oh, that's the original. Okay, yeah. So age input box. Breed name input box. We'll just call it breed input box. Breed name, whatever. Breed name input box. Okay, so we've got these 3 input boxes now. We've still just got the add button. So what do we want to do on add? We're going to do something a little bit more complicated, but not really. So what we're going to do, forget this line is in here for right now. Dog, our dog equals new dog, and it will be name input box, or that's breed name input box. Name, oh, it's just input box dot get text. That will be the name of the dog. Age input box dot get text, but we have to parse this into an integer dot parse int name textbook box dot get text integer dot parse, or no, it's just string. Breed name input box dot get text. Okay, so now that we have our dog, we are going to, instead of adding a string to it, last time, as we can see here, we added input box dot get text. Our list model now hates this because we're no longer a list model on strings. Rather, we are a list model on dogs. So let's go in here and add our dog to the list model instead of the string. And let's see if it works. And oh, does not field does not exist. Oh, I didn't do the thing when it asked me to. Name input box just doesn't exist. Okay. I should have hit yes to that dialog asking if I wanted to rename something. Awesome. Okay, so this is not going to work as we hope it does, but it is useful to explain. So we'll call the dog Marcus. The age, we'll say the dog is 12, and golden retriever. Okay, we add, and what do we get? Does anybody recognize that? That would be the string that you get when you try to print out an object that has not overridden to string. It is the class type and then a reference location where that actually lives logically in memory. So that's not too useful to us. But if we want to generate something nicer, by default, this list selection model will look for the object's toString method to see what it should display to the user. So we can go to @generate toString, and let's say we want the name in our toString. That's kind of wonky, but let's run it like this just to see what it looks like. So now we're going to call it Fido 12 and I don't know, Bulldog. Add. So now we see that we get the exact contents of that object, the new dog we created. We get the contents of its toString method to appear in the list, which is cool because we are now able to change what gets displayed. This could be a very, 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 very complicated object with 5,000 awesome configurations to it. And the user doesn't necessarily need to know that. All they have to see is the information that you've decided they are interested in. And in this case, we've chosen dog, name equals the dog's name, and some brackets enclosing that stuff. So that's cool enough. Continuing on with what we can do to play with the JList, let's make a remove button. Why not make a remove button? JButton, and we'll put it right beneath add. We'll call it remove. We're going to call it remove button by default, or we're not going to call it that. Swing will call it that, and we will accept it. And then we're going to make another button while we're in here called remove all. So it's going to name that remove all button for us. And if we added to this, if we added to the JList and what's visible to the user by calling our list model.add, I reckon we should be able to remove stuff by calling our list model.remove. So we're going to take the delete button or remove button. And like all the other buttons, we're going to add an action listener to it, new action listener. And when this button is pressed, we want to take our list model dot remove element our list model dot get our main list dot get selected value. It doesn't matter which one we choose, selected value or selected index, as long as we're using remove element in a case that it's non-ambiguous. So if you're storing ints and you're removing elements at an index, just be careful that you're removing what you think you are. In this case, we know that we're removing dogs. We know it's only going to remove the selected dog. So hopefully this should suffice. So we're going to make a dog, Fido 1. And we'll say, I don't know, Flav, I can't spell Rodor, add. Okay, we've got Fido again over here. We can't select Fido. Okay, we've got ourselves a little bug. When I disabled that text box earlier, we need to, or not the text box, the JList, comment that out, and it should now be re-enabled. Then we can make selections. That was kind of why I demoed it, to show that you couldn't make selections. Well, here we are. Fido. Age 5, and it is a bulldog again. Add dog name Fido. So we press remove and it goes away. Similar to any sort of Java collection, when you remove an element, it is no longer in there and it is thus no longer displayed, because what is displayed is the contents of that list model. So to program remove all, I mean, it's a very, very, very similar idea. Remove all button. And in this action lister, we're going to remove all elements. Perfect, just like that. So what we're going to do now is we're going to make, I don't know, 6 dogs or something. Mac 5, Maltese. Sure, add. And then we're going to make Mac 2. Who is a golden retriever. Again. Okay, dog Mac 2. We press remove all, and all the dogs go away. That's what the button promises. That's what the button does. Now let's talk from a user experience standpoint. I named the dog Mac 2 because I was too lazy to press backspace. So how about on our add buttons or our remove buttons, we're going to make a method that will clear out all of the input fields. So we'll just make a method private void clear out input fields. Input box dot set text name and or no age input box dot set text, and we'll do breed name input box dot set text. Cool. So now whenever we press the add button and after we have accessed the information that we need to, i.e. after these calls to get text, we should be able to clear out input fields and then more easily allow the user to enter different data from the previous dog that they had entered. Name is Harley, the age will be 7, and the breed is a, I am having such trouble doing this, black lab. And we add. So we added Harley, and now our fields are not visible or not filled in, so it's an easier time to add other stuff to them, which is cool enough. Great. What else can we do with JList that might be useful? Well, we talked about adding a select feature. So let's say we want to update the dog. And instead of just adding a new dog over it, deleting and re-adding, we want to actually modify the dog that is selected. Well, that is quite possible as well with minimal additional programming required because of the way the JList is created. So we're not even going to add a button for this one. We are just going to, upon selection, our main list dot add list selection listener, new list selection listener. So when the list selection listener, or when the list selection listener value change property is called, when this event gets fired off, it means that the item that is currently selected by the user in the list no longer matches the last recognized value that the user has selected. So we know that our main list has a dog in it, in its model. I'm going to rewind a bit. We know that there is a dog, and the dog has 3 properties, and we have 3 text fields. So I think for sake of loading the dog back into those text fields, we can input box dot set text e dot list selection model, or our list, our main list dot get selected value dot. So we have to cast this to type dog. We know that our list has type dog, so we can safely cast to dog. And then after we cast to dog, we should be able to get its name dot get name. Now we'll do input box dot set text, or not input box, age input box dot set text dog. Actually, I should do this because this is better. Dog new selected dog equals that. So now we can use new selected dog instead of repeating all that code. New selected dog dot get name. Get rid of that other stuff I started typing there. New selected dog dot get age. And this is an int, so we have to use integer dot toString to make it into a string. Nothing too crazy there. I've got a parenthesis mismatch now. Cool. And similarly, finally, for the breed name, input box dot set text integer dot toString. I know this is the breed name, so we can just do our selected dog dot get breed name. So now when we change the list model, we should end up refilling our dogs. when I say refilling our dog, we should end up populating the boxes that allow us to input the data for the dog. So we'll call dog named Melanie, age 3. I hope no one in here is named Marcus, Melanie, Fido, or any of these other names I've been using. I don't mean it personally. I'm just mentioning because Melanie is a person's name. Breed name is Golden Retriever. Why is that so hard? And we add, so we have a dog named Melanie. When we click Melanie, all the data gets added in here. So this is not fully working as an update button yet, though. However, because what happens when we press add?
Just they were running short on time.
Okay, we'll try to wrap up. Oh, we're doing that. Okay, I thought it was the 2, but we're splitting it. Okay. So what we're going to try in the next couple minutes, pound out the feature to do the update, and then we will, well, I'll open up the floor for questions and comments and whatnot. Int selected index, actually, I shouldn't even need that. So we'll make an update button really quick. Put it underneath add, we'll call it update. So the IDE will call it update button for us. And we'll do update button dot add action listener, new action listener. If our main list dot get selected index is greater than -1, our main list dot, we're going to pull this dog stuff as well, and our main list dot get selected index, and our main list model dot remove dot get going to use the selected index, and we're going to make it equal to I'll set our list model dot set element at, we're just going to get that new dog we made earlier, and this should be ready in 1 second. So we're going to get the code we used to make a new dog earlier. So if we have something in our selection, so the selected index is greater than -1, 0 is the smallest selectable index, set element at our main list dot get selected index to be our dog. And I did that in reverse. It should be our dog and then the other thing. And hopefully this works as expected, and then we can do some questions if anybody has any. I was originally intending for this to be a 2-hour ordeal, but since we split it into 2, it was not. They will be resuming tomorrow, and we will not be doing the same application. We will be doing a different application with different concepts, but there will be some reinforcement of things because there's a lot of overlap between action listeners and buttons and all of that stuff. So let's see if this works. Marcus 5 and Golden Retriever. Going to add. So now we've selected Marcus and we'll call him Mary instead. Update, and it updates the dog to be Mary based on the selection that we have, or the fields we have in this box. However, instead we can go to update Mary. This is breaking because we didn't design this to work in this way. The value changed by default and we didn't have code to support that. But the idea is you can listen to what the user is selecting in the lists and respond to it with whatever it is you should so choose to do. That was a bit chaotic. I try to cover a lot of ground and not focus in too hard on anything. So I acknowledge that I may have left some things up in the air or not explain things as well as would be necessary for someone to fully grasp this. So I would like to open the floor for questions. If anybody has anything that they would like clarified or anything that I hadn't discussed that you'd prefer to see discussed tomorrow, any ideas for like a cool app to develop tomorrow that you'd actually want to see instead of just these list manipulation things. Yeah.
And about this section pretty basic.
Yeah.
And the modern apps, it looks so fancy. So they actually.
Yeah, so there are, well, let's talk about what actually looks fancy. We can actually change the way these buttons appear to look like fancier buttons in that they can actually appear as an image, and an image can be as fancy as you would prefer it to be. We can actually write our own controls and forget the JButton class exists entirely, and you could render CSS in the box. You could just take something that renders CSS and get the same kind of buttons you'd see with React. The cool thing with all these new JavaScript frameworks is they're designed to do this, though. They're designed to update and look great on all these screens and be configurable with CSS. I would not actually ever recommend using Java Swing for a public-facing mass client, mass like people using it app. I don't think that it's the right choice. Yeah. Yeah, right. Those, this isn't going to run well on a phone either. You should use something probably for that kind of thing that is platform independent. However, I would say that this stuff gets really useful when that isn't important and you're on a budget. It takes a lot of time to make stuff look nice and get that user experience ideal. So if you can just provide someone with something that works, you can either get out of a testing phase for a product, so you can hire new developers to make it look nice and even maybe port the whole thing to React and JavaScript. This can really speed things up if you're not so concerned about that. There are a number of other interesting little things just on what you're saying that might look a little bit fancier or better. So if we go to preview, this allows you to change these different look and feels. You can change them, and it should update how Swing looks for the user. You can download more look and feels. People have made more modern looking looks and feels, but you're not locked into what Swing is rendering by default. Like, you can go back to Windows Classic. If you're really into this kind of thing, you can make your own look and feel that might emulate a particular React theme or CSS set. But it is a good point that this is generally not the nicest looking or more modern solution. If you were hellbent, Java GUI, modern solution, there's another library called JavaFX. It's a lot more involved and a lot more config file. But I will actually show some of that toward the end of tomorrow's workshop to see the differences and how that can look a lot prettier. But again, if you want to like play around with this or like port one of your homework assignments toward GUI, it might be more of a headache. And I found, having tried to learn JavaFX before I started working with Swing professionally, I got lost in it. I felt like, wow, this is so overwhelming. I don't even know Java looking at this. But then after having played around with Swing as much as I have at work and whatnot, I feel as if everything is more tangible. I've learned the language of Java GUI stuff. And seeing like how I edited these properties in this property manager, the other property managers were a bit more digestible. If there are any further questions or things, comments, concerns, suggestions for tomorrow's workshop, please let me know. Hope that there are some takeaways to this. I should also mention that this whole idea isn't too specific to Java. I mean, sure, you've got Swing, sure, it's single-threaded implementation, platform-independent GUIs, but the language of action listeners and binding different controls to one another and how they're backed, you're going to find that all over the place. For React or JavaScript, you might have an on-click lambda instead of .add action listener. But it's the same logic that you can use to interact with these things. I think that this app would be just as easy to program in something like JavaScript, even if you only knew what you had known from this, because you Google. Like, as software engineers, we are professional Googlers. So if nothing more than learning some language involved in this stuff, I hope that you've taken something away.